This conference will now be recorded.
Hello, everybody. Jordan Girth here with the National Weather Service Office of Observations. Thank you so much for joining us for the Satellite Book Club Seminar Series. This is session number 177. The title of today's presentation, Forecasting Marine Hazards with Limited Observations and Verification. I'm pleased to have Michael Fulmer, the Warning Coordination Meteorologist from the Ocean Prediction Center, as our presenter today. The facilitated discussion will be led by Rebecca Duell, meteorologist from the Forecast Office in Burlington, Vermont. As you just heard, this session is being recorded, and as always, there is an opportunity for Q&A after the presentation, so please post your questions in the chat. If you have not signed in with your full name, please note your name when asking a question in the chat so we can follow up if necessary. We know many of you are fresh back from the AMS annual meeting. We are looking for future presenters. Please contact the Tower S team, Grishad Bowman and Emily Maddox, if you would like to present as part of the Satellite Book Club. As a reminder, it just needs to have some satellite in it. It doesn't need to be solely on a satellite-related topic. And the training team can help create training materials that may be unavailable or point you to materials you may be unaware of. Ross Van Til is your point of contact for that. I'd like to thank our Tower S team, Grishad Bowman, Emily Maddox, and Lee Byerly, the Office of the Chief Learning Officer, the GOZAR and JPSS program, our presenter, facilitator, and all of you for being with us today. Without further ado, let me introduce Dr. Michael Fulmer, a new warning coordination meteorologist for the Ocean Prediction Center in College Park, Maryland. He's been a meteorologist with OPC for 4 years. Prior to these roles, he was a satellite liaison for the satellite programs at OPC, the Weather Prediction Center, and the National Hurricane Center Tropical Analysis and Forecast Branch. Although he has a tropical meteorology background, satellite and mid-latitude weather have become his main focus. Michael, welcome back to the Satellite Book Club.
All right, thank you very much, Jordan. I appreciate it. I appreciate that introduction. And good afternoon, I guess now. I just got off an overnight and about to go back onto an overnight, so this is my middle of the night. I'm going to be talking with you about some of the forecasting challenges that we see at the Ocean Prediction Center and how we've integrated satellite into the fold with our NWP as well as numerical weather prediction, as well as ancillary data sets. So I'm going to jump right in. I have quite a few topics to cover here. So I always like to start off with a surface map to give everyone an idea of how busy it can actually get in at least one of the oceans. Remember, we are looking at the Atlantic Ocean and the Pacific Ocean. So here you have a surface map from back in October of 2022 with a hurricane force low. I think the pointer should work here in the Gulf of Alaska, as well as a recurving tropical storm, Haitang, out here in the Western Pacific. And then you'll also see a complex storm force low up near Kamchatka Peninsula. This is part of Siberia and Eastern Russia over here, the Sea of Akashk. A lot of territory to cover, so we need a lot of satellite in order to cover that territory and be able to give the mariner the best possible analyses as well as forecasts. So one of the things we've really started to incorporate is some of the RGBs or multispectral satellite products to help with some of the analysis, as well as maybe highlight some features that we sometimes cannot see as easily in the single channel satellite imagery, but really they work in tandem. If you were to walk around forecast operations, you would see forecasters using a mixture of the different satellite products that are available to us. But this is just some of the ways in which we're using it for the service analysis, storm force, hurricane force diagnostics. You'll see the air mass product in particular is heavily used for many of these different features. Extratropical tropical transitions, fog analysis using the nighttime microphysics, and so on and so forth. The dust diagnostics is largely done more at the tropical analysis forecast branch at the Hurricane Center when they're looking at waves coming off of Africa. But the dust does get into OPC's waters every so often as the summer goes on. So one thing I want to do is ask a question right off the bat, and you can put your answers in the chat if you have an answer. I think most of us are familiar with how busy the Atlantic hurricane seasons have been over the last many years, but on average, we have approximately 7-8 hurricanes in an average Atlantic hurricane season. So my question to the audience: how many hurricane force lows, these are non-hurricanes, so non-tropical, but hurricane force lows that reach at least 65 knots, do you think typically occurs in the North Pacific and the North Atlantic each winter? And I'll give it a second to see if anyone wants to chime in with an answer. Okay, I see a 50 popped up there. Anybody else want to venture a guess? 36, that is a very precise number. Thank you, Brian. All right, for those that may be a bit timid, we tend to see, depending on the basin, the Pacific tends to be somewhere in the 35 to 40 hurricane force lows, and the Atlantic actually is a little bit higher, closer to 40 to 45. But the last couple of years in particular have been rather bearish for the forecasters, or bullish, I should say. Bearish would be kind of nice. Bullish in that we've had a lot of big hurricane force lows, and sometimes once you get done forecasting, analyzing, moving, a system onshore, a whole new hurricane force has taken shape behind it. Tends to be kind of relentless. So one of the things we do is we'll open up something like the air mass RGB, or even just some of your water vapor channels at 6.2. Some forecasters look at the 7.3 on whether it's Himawari or goes west or goes east. It's great for identifying some of the little features. You can see this small feature here near the Kuril Islands, south of Kamchatka. But then when you look in the larger scale, you can see, the air mass product showing the different air masses associated with the whiter, brighter clouds that you would expect with deeper convection or high ice clouds. As we're putting together our service analysis, though, you'll see, we tend to use a lot of visible if it's available, or we'll use the shortwave infrared at night. And I'm showing you how I did an analysis by plopping down where the lows and the highs are based on the numerical weather guidance, so whether it's the GFS objective analysis or the European, doesn't really matter. Depends on which is handling the pattern better. And then from there, we'll pull up our observations. And I'm sure I don't need to tell you, we really have a lack, would be a polite way of putting it, of observations over the open ocean. So this, looking at the open Pacific, our forecast area is north of this blue line right here. It's about 30 degrees north. And in this area bounded, this is the Ocean Prediction Center's high seas area, where we actually produce a text product. Outside of this, we still analyze and go right up to Japan's waters and Russia's waters. So we do a complete analysis, including the Arctic. And then this extends over to the Atlantic. I'm just showing you the Pacific. But as you can see, a vast part of the Pacific, you have very few observations to choose from. So satellite winds up being one of our greatest tools. We do get the help from some scatterometer data. ASCAT-A was decommissioned in 2021, but we still are using ASCAT-B and C, and there's a new OceanSat that we are hoping to get our hands on pretty soon that will help with larger swaths. But this definitely helps with identifying where areas of low pressure and high pressure are located, if you can match the times up well with the analysis. So I want to go through a couple cases that I would call challenges that we have faced over the last few years. I've been collecting these one by one to see where numerical weather has maybe led us a bit astray, and we've had to figure out how we can use the real-time satellite data to make quick decisions. So in a situation, this first situation of what I'm calling a surprise gale, you could actually see some of the ice cover at night here over with the colder temperatures over the Sea of Akashk. You do have an ice edge. I didn't put it on here because I didn't want to take away from the imagery itself. But right along the ice edge, you'll see these little swirls that develop. These are polar lows. You can sometimes see these polar lows develop in the Davis Straits west of Greenland or even on the east coast of Greenland. They're kind of interesting in that they can sometimes have very similar characteristics to a small tropical cyclone. They're very short-lived, and sometimes when they make landfall, they fall apart, similar to what you would see with a tropical cyclone. But in this case, we had a couple of these small lows. Here's the first one that's moving to the east of Siberia. Here's a stronger one, and of course, everyone I'm sure can notice the larger cyclone, the more mid-latitude. This is very similar to a Shapiro-Kaiser type of evolution coming off of Russia and then heading out into the Sea of Akashk and out into the Pacific. So as we're going through the forecast process, we had some ASCAT data available, and none of the models were forecasting anything above a subgale. So about 30 knots along the ice edge up here in eastern Russia, southeastern Russia. I zoomed in a little bit just so you can see with the imagery overlaid. This was our low. This is the second one. The first one has already moved off deep into the Bering, heading up towards the Chukchi. And here is our forecast, our actual service analyses, sorry, with the forecast points. So you can see we have a 24-hour forecast point for this low that was very easy to see coming across the Sea of Akashk. And then these two small polar lows, one of them already is occluded, and then you have another one here trailing behind. Then we happen to get data of opportunity, and you'll see that you have gale force winds. So in the yellows, that's between 33 and 42 knots. We have achieved gale force winds right on the edge of the ice, and it's too close to not call at this point. So I happen to be the forecaster that had come in for this shift, and I had to quickly put up a gale warning for that event. Again, zooming in, you can see the ice edge is right along the coast. Some of these gale force flags are actually within the open water. So it was pretty close in the cold conveyor belt side of the little polar low here. Again, the larger system, the models handled that very well. The models did not do a good job on this little system. So as the low was pulling up along the ice edge, I put the gale warning in effect north of the occluded front as it then headed up and would wind up dissipating once it crossed over the ice sheet. So again, kind of an interesting, it's a non-tropical case, but sometimes has some very weird tropical-like characteristics that occur along those ice edges. So the satellite as well as the scatterometer data is really what we had to use in this case. There was not enough model guidance to actually help us make this determination. So I have another more recent case from January of this year. This is another case where I was working with my colleagues. We had done what I think is a great job of identifying where you had a low that was going to rapidly intensify well to the west of the Oregon-Washington waters and intensify from 1,008 to 980 millibars within that 24-hour period. We had developing storm. So everything seemed to be going well, and none of the model guidance was showing winds over 50, 55 knots. So the forecast was moving right along. As the storm moves closer to Vancouver Island, this is Vancouver Island right in here. The Hecate Strait is up here, part of British Columbia. So as the storm starts to make the right-hand turn and move more due east, we have a storm force that was issued at 6Z, 981 millibars. Again, no model guidance above 55 knots. I was really scrutinizing the data because something I saw on the satellite was bothering me. So here is that satellite animation. This is GOES 18 air mass RGB. And you can see how violently this storm intensifies. Starts as a double barrel shortwave that then meets up with the baroclinic zone, rapidly deepens a low along that baroclinic zone. And one more time, as you can see, the deep reds of the stratospheric intrusion, as it overwhelms and actually then co-locates with what becomes the parent mid and upper level low, you'll see how quickly the bent back front wraps around. So you can see as the kind of comma head forms right in here. We've seen this before, and usually it's associated with hurricane force winds. So I started doing the talking in our chat with our forecasters on duty and with Mike Rowland, who is working the high seas. And I said, you know, that really looks like it's a hurricane force. And then ASCAT came in. And it's going to be really hard to see up here. It is somewhat close to the edge, but we had multiple 65 knot flags within the broader, slightly broader storm force winds. Of course, you know, it just so happens that the gap shows up right where probably the best analysis would have been with the winds, but we had enough there to actually then go back and relaunch our map with hurricane force. So satellite definitely gave us some indications. I used air mass here, but most of the other satellite imagery we could have used would have showed similar details, maybe not so much in the water vapor channels, but in the shortwave IR, you would have been able to see some of the features at low levels that indicate to us that a hurricane force event is underway. So my final example here that I want to show you is a storm that happened in January of 2023. I won't be mean and ask if anybody actually remembers this. I don't expect you to. But we had a subtropical storm that was post-analyzed. And here was the track. I had actually plotted this track before while we were going through some scrutiny over what exactly was the system and how do we characterize it. So you can see an extratropical cyclone that undergoes a subtropical transition, makes landfall in eastern Nova Scotia, and then eventually makes its way up into Labrador, all the while falling apart as it does so. So that definitely raised some eyebrows by itself. So just showing you some of the work that was done by myself as well as Philippe Papin and some of the other hurricane specialists. We put together some of these slides as we were going through and debating what exactly do we do with the storm. It already happened warning wise. I think everyone did a fantastic job. There was great coordination between the Hurricane Center and Ocean Prediction Center during this event. We had storm force warnings out along the Gulf Stream, all the way up to the Nova Scotia waters. And as far as I'm concerned, shipping seemed to stay away from it. So from a public standpoint, we did everything right. And this was a great success from the warning perspective. When it comes to then trying to figure out, okay, well, what exactly were we looking at when you have an eye-like feature developed? You can see in the phase space diagrams here, both the GFS and the European showed that we did go into a symmetric warm core system in the middle of January. Not completely unheard of. You do get warm seclusions with some of your larger storms that are typically storm force or hurricane force. But this one had some rather unique characteristics to it. Here was the track in relation to the Gulf Stream. It did go over area of 23 to 24 Celsius water, I believe briefly over an area that was close to 26 Celsius. That would do July proud. And here we are in January. So a big testament to how warm the oceans have been recently. And here is your sea surface temperature anomaly map showing just how much above normal these sea surface temperatures were during this event. There were some very obvious pockets of cold upwelling on either side of the Gulf Stream, but the storm really did track as perfectly as you could through the Gulf Stream, then across the North Wall and accelerated, still maintaining some of its subtropical characteristics as it made landfall in Nova Scotia. And again, those waters were 2 to 4 Celsius above normal for the time of year. So pretty impressive. So this is a case where you pull up anything you have available to you as far as the amount of satellite data or ancillary data you can get your hands on. And here was the 37 and they called 89 gigahertz, but the higher resolution RGB from the polar microwave instruments. And as you can see, you have what looks to be a tropical cyclone in the middle of January with an eye-like feature as well as banding features. You can see the banding on both the eastern and western quadrants, fairly symmetric. And then once it made landfall in eastern Nova Scotia, notice it falls apart, similar to what a tropical cyclone would do. Any of the deeper convection had moved off to the east, it was being sheared, and you were left with a rather naked looking low level center as it moved into the Gulf of St. Lawrence. So here is the air mass RGB animation of this event. And notice that as the low forms along the Gulf Stream, it has some of those polar low characteristics I showed you in the first example, but then winds up looking fairly tropical, and again, makes landfall and then starts to fall apart as it heads up towards Labrador. So the question became, well, what were we looking at here? Is it a tropical cyclone? Is it a subtropical cyclone? There were arguments for and against with the group of us that were looking at it. It was enveloped by it was within, I should say, a large trough, a very, very cold trough at that. And so just the difference between the cold temperatures aloft and that very warm, for January bath water, and you wound up being able to create the processes that give you a tropical looking subtropical storm. Say that 5 times real fast, in the middle of January. So a very unique case, but it was a good way of showing how you can use multiple satellite tools along with some of the other data that's available, like sea surface temperatures and so on, to analyze these. In this case, it was a post-analysis, but during the actual events, again, the modeling did actually do a pretty good job, and I believe we peaked the storm at about 60 knots, so just below what would be hurricane strength. And the final example I was going to give you, we do deal with fog quite a bit at OPC. We don't have a lot of time to do fog analysis over open water. We tend to do a lot more of a focus in our offshore zones, which would include the Gulf of Maine all the way down. You have Georgia's Bank out here. And then you can actually see in the nighttime microphysics, this is the Gulf Stream with an eddy to the north. So you get a lot of great features that can show up when you're combining some of these multispectral products. And one of the things that's kind of fun about this is you can see the delineation between what looks to be more fog. You can see it's a little more transparent to the north versus warmer cloud or stratus just to the south of this. And it's right near where that eddy is interacting with the Labrador current. So a bit of a feature there. And with that, I'm actually done. This is just a long animation showing you how stormy the Atlantic. I wanted to give the Atlantic a little bit of love here because we did a lot in the Pacific for this presentation. But with that, I will take any questions or any discussion. And thank you very much.
All right, I think everyone's good. Thank you so much, Michael. That was great. I'd like to encourage all the attendees to please stay on for the discussion. We've got about 20 minutes here, so we can really get to some interesting topics. We're going to start taking questions from the field forecast offices and regional headquarters, as well as anyone else who's on the call right now. And please, a reminder, please specify your full names in the chat when you ask a question. We'd also like to encourage everyone to please complete the feedback survey that's posted in the chat room. We'll have that posted shortly. Emily's going to post the link, and we'd love if you can share any feedback you have on this session in the Satellite Book Club or the Satellite Book Club in general. So go ahead and look out for that. Yep, that's right there. I'd like to remind everyone that in a week from today, on Thursday, February 22nd at 12 p.m. Eastern Time, We'll have Bill Line, a physical scientist from NESDIS STAR, who will be discussing tracking widespread fog with satellite imagery. So definitely stay tuned next week for that one, or 2 weeks from now. Oh, that's next week. That's next week. Finally, I'd like to encourage everyone to contact the Tower S team. So we have Kashad Bowman and Emily Maddox on the call right now. If you have any questions about the Satellite Book Club or for configuration of satellite products, they're happy to help. Let's see. I think that is all that we have. I'd like to open up now for any discussion questions. If anyone could post in the chat, if you have any questions for Michael. I can go ahead and lead with a discussion question, Michael. Thank you so much for that talk. That was really interesting. You talked a lot about the unique challenges that OPC has, and I know we have a lot of forecasters from forecast offices here on the call. For your forecasters at the Ocean Prediction Center, do they have a background at WFOs generally, and how do they adapt to the unique challenges of forecasting in an area where there's just not the data coverage that we're used to in the forecast offices, and do they usually find that really challenging, or how does that go?
So that's really a great question. As I think about it, I'd say we have a pretty diverse background. You get some forecasters that have come from the WFO world, some that come from WPC right down the hall, which helps with some of the service analysis because they've already gone through the rigor of their training program. But we have actually had forecasters in the past that came from the private sector that would do ship routing and forecasting for some of the private companies along the Gulf Coast, for instance. And some that just come straight from the universities. I've actually, in the time I've been with OPC, which is now rounding 13 and a half, almost 14 years, which I can't even wrap my head around. We've seen quite an array of forecasters that come in. So right off the bat, we do our best to train them on the different products that we have available to us. And we're actually thinking of starting up a bit of a service analysis, maybe not boot camp, probably wouldn't be a good way to call it, or a good thing to call it, but kind of an overview, especially for those that haven't done a service analysis. I'm not sure how many out there the last time you did an actual service analysis, but whether it was in college or for a job in the past, it can be pretty tenuous. There's a lot of detail to cover. So, but yeah, good question.
Thank you, Michael. That's really, I know I used to work in Alaska region, and we had a lot of the same challenges. We had to honestly think about forecasting in a very different way than what I was taught in school when you don't have, all of that data that we're used to in the lower 48. So a lot of your talk brought back a lot of memories of forecasting up in Alaska as well, and how we just had to rely so much on satellite with no radars or anything really for a lot of our area. So very interesting.
We definitely relate to our Alaska forecaster friends, so we get it.
Yeah, you become an expert in satellite meteorology when you're in an area without any real data.
Yeah.
So there's still plenty of time. Let's see if you want to get in your questions. We do have a couple of comments. Sheldon Cusselson says, nice job, Mike. I'll be sending you some URLs to new and revised upgraded satellite moisture products that he's working with Sierra, so that could also be helpful. And he also put a link in for an example, so you can check that out later. So another question we have then, so during these storms that were featured in your presentation, do your forecasters work directly with any of the customers? Do they work with the shipping? Do they have, when you see a hurricane or a storm force storm, what kind of DSS do you guys provide at that point, working directly with the customers? Is there any sort of DSS?
So we don't typically hear from, say, a random cargo company or a cruise line per se. Usually when we're hearing from them, it's because something happened and they'd like some more information on whatever the event may have been. One of our biggest customers actually is the U.S. Coast Guard. We do DSS with them once a week. We send out a Wednesday morning, roughly morning to midday update that'll cover, what's going on now as well as the next 7 days. and we do one for both the East Coast and the West Coast. So we cover mainly our offshore waters, but in general, if there's something happening just a little farther out, we'll try to include that. We're also starting to interact, and as I came on, I'm warning as the new Warner Coordination Meteorologist. That's been one of my tasks, is to start reaching out to some of our customers, which include Navy. But we have a lot of people that use our products, a lot of cargo, a lot of even regattas, some of the sailing vessels that go out in private use. But we don't have the capability to just interact with the customer directly. So Coast Guard's probably, for the time being, the one we will interact with the closest, and then they will blast out our DSS to anybody who has signed up on a subscription.
Interesting. I'm sure they find your analyses and forecasts very helpful for the Coast Guard. We've got a question in the chat from Becca. She says, great presentation. Thank you, Michael. She wanted to know, how do you and your staff diagnose areas of freezing spray in your analysis? She noticed there were a few pockets of freezing spray analyzed in your example of the polar lows.
Yes, freezing spray, that's actually become a really interesting topic. We're going to be having a mariners workshop coming up in April, and that was one of the things as the planning committee was putting things together, is the topic of freezing spray. There isn't a lot of in-house freezing spray expertise. We do have someone in our applications branch who has worked quite a bit with it, so we're actually continuing to learn. What we'll wind up doing is we used the best data we can get from the numerical models, whether it be the GFS or the European. We're able to see both, and pretty much once you start to see moderate to heavy, just go with it. It's better to be safe than sorry. But we will look at what Alaska's doing. You brought up Alaska and even Canada, and see, there might be some local expertise there that we then tap into, so that we can make sure that, first of all, we have a consistent message across the board. If someone's changing from Alaska waters to OPC waters back to Alaska or Canada, we want to make sure there's a consistent message. So we tend to rely on our neighbors a bit, and get some of that local expertise. But like I said, it's a big learning curve. Heavy freezing spray was something I never dealt with coming from a tropical background. So yeah, stay tuned. I think we're going to continue to learn more, and like I said, at the workshop, I think that'll be a big help getting some expertise.
Awesome. Thank you, Michael. And Becca says thank you in the chat as well. Another question from Aaron Jacobs. He's from Alaska as well. He totally understands about the lack of OBS and the necessary need to use the satellite data. But he asks, for the polar low surprise example, do you know if fishing boats were around to benefit from the updated forecast?
Not for that particular case. In recent years, we're able to see a little bit more. It's not something we can share with the public, but we have access to see what kind of ship traffic is out there over the open waters. And it is helpful when we can tell they're getting the forecast, whether it's from us, whether it's from Alaska, whether it's from some other private sector or agency. It is very helpful to see how they maneuver and move around. And one of the biggest cases, I know it was brought up about polar lows, but Merbach a couple of years ago was an excellent case where we actually had a student, excuse me, I lost my voice. We had a student do an analysis of how ships responded and how much time it took them to respond to the tropical cyclone as it was recurving over OPC waters and then transitioning to a powerful hurricane force extratropical low. Like I said, we won't necessarily get phone calls, or we won't hear directly, but we can see how the traffic is responding. And so in that case, that's probably the best feedback we can get. They stayed out of trouble. That's excellent. When it comes to a polar low, hopefully no one's really that close to the ice edge, except for maybe some of the more adventurous fishing vessels. But we just want to make sure that we're getting the warning out there, because you never know. There could be a Coast Guard cutter up there. There could be someone who just ventured into the wrong area.
Fantastic, thank you. Dan has a question. Dan Lindsay has a question. He's asking, when is OPC going to move away from the colors associated with RGBs and GEMPAC and NAWIP? Sorry, I couldn't resist asking this. That's what he said.
Dan, that's not fair for you to ask me this question. Although I believe we were supposed to be moving towards better colors back in 2008, so I guess time has flown. We are actively working on the process of moving into the AWIPS world, where we will no longer have to work with 95 to 96 colors in the GEMPAC and AWIPS world. I will be honest though, we're already pushing that. For some of the RGBs, for instance, or some of the products that we really don't get the right, what I would call the best benefit from the NAWIPS world. We're pushing the forecasters to look more at those, say, the convective types of RGBs. I think day convection would be one, or day cloud physics, or phase, day cloud phase. They look much better in the AWIPS world, and if we have to interrogate any type of convective system, that has been what I've been pushing for, and now with our new satellite liaison, Chris Smith, I think he'll be a big help in pushing us into that world. So fear not, it's happening, but unfortunately our analyses are still done in the NAWIPS world.
All right, Dan, does that answer your question? We have another question from Jammer. Sorry if you already covered this, he says, but do you use ocean color data for any of your marine hazards forecasting?
Not as much. I know some of the ocean color. When I was a satellite liaison, I was part of some of the discussions with ocean color, but that hasn't been incorporated as much yet. I know the ocean applications branch under Joe Sinkowitz has been playing with that and working with others that create those products. So nothing yet that I can say is actively being used in operations.
Great. All right, we still have a few minutes. If anyone else wants to ask a final question or two for Michael, I will go ahead and ask you another one. You talked about the storm that moved into the Canadian Maritimes. How much coordination do you do with Environment Canada during a system like that? Or
right
if any?
now, honestly, right now, very little. That again is another one on my list of things to do as the WCM. And I've already started conversations. I'm hoping to meet up with Environment Canada, both the Atlantic side as well as the Pacific side, to learn a bit more about their processes, but also figure out where we can coordinate. Remember what I said, we want to make sure we're consistent, you know, and sometimes different countries do things differently as far as, you know, what the warning thresholds may be, things like that. So that there just hasn't been the bandwidth, there hasn't been the staff, there hasn't been the time, and so I'm working on it, and we will get there. But for the time being, we will look at their forecasts, and I believe vice versa, they look at ours as well.
All right, cool. Yeah, that's something we're working on growing as well. We're a forecast office that borders Canada as well, so we're building that relationship too. Another question from Janae Kent. Do you have any suggestions on how sea surface temperatures could be improved so that you could have helped better with these events or other forecasted events in the past?
I think it comes down to using it more in operations. We have brought up, I think in the last, I want to say the last 3 to 5 years, as the sea surface temperature anomalies have been making more news, you know, literally making it into some of the mainstream media, social media, of how we can better use that when we're looking at patterns that will lead to multiple hurricane force lows, for instance. Another thing is, you know, coupled with that, you know, where do some of those teleconnections? I think the majority of people on this call would probably have a good understanding of the North Atlantic oscillation, the Pacific North America pattern. But there's some lesser known ones like the West Pacific oscillation that I've really been keying in on with our forecasters. It seems as though when it goes into, let's say, a strongly positive phase, we will have hurricane force after hurricane force caught up in a 200 knot, 200 millibar jet over the Pacific. And those are some of the worst shifts you can work because you barely have time to go to the bathroom. I mean, it really can get that angry out over the open ocean. But understanding how the sea surface temperatures play into that and could help with maybe a quicker reaction on our part. Mostly, I'd like it to be less reactionary and more proactive, looking at our forecast and saying, hey, I saw this before. Models are pointing at it. Look at those SSTs. They are 4 degrees Celsius above normal. We're not quite there yet, but I would love to see us start to use that data a bit more operationally. Sorry, I feel like I'm giving my wish list of how.
All right, perfect. Let's see. Yes, we have, I think, one more question that we have time for from Jamie Daniels. Is there any satellite-based information that you are not getting that may provide information that would help OPC forecasters do their job better?
The ultimate question from Jamie. There's never going to be a time where you meet a forecaster at either OPC or the Hurricane Center where we're not going to wish we had more. There's always limitations, whether it be bandwidth, pipe size, different things like that, just to get it into our systems. But the scatterometer data, I know the US doesn't, to my knowledge, doesn't have any plans to go into that. And so we rely on our international partners. That's been a huge, huge benefit to open ocean forecasting, whether it's tropical or non-tropical. So more coverage of scatterometry, I think, would help us do a much better job. Even more microwave imagery and learning how to better use that in a forecast framework as opposed to looking at something, from a post-analysis. We've gotten better and we're getting more coverage, but I think those are 2 tools that I will always say, probably to my dying day, that I wish we had more. And as close to real time as possible. But when it comes to the high resolution imagery from the geostationaries, the higher resolution imagery in the poles, the time is getting better. The latency is getting much better. So I think it's just a matter of, all these great tools are out there. We need to have the time to train the forecasters on how to actually use them.
Awesome. Thank you very much. We are getting close. We're going to wrap this up in just a couple of minutes. So thank you so much, Michael. And I'm going to pass this back to Jordan for some final remarks.
All right. Thank you so much, Rebecca, for that expert facilitation. And thank you once again to Michael Fulmer from the Ocean Prediction Center for that great perspective. Just as a reminder, the Satellite Book Club continues next week. Yes, February is flying by. Thursday, February 22nd at 12 noon Eastern Time. We have Bill Wine from NESDA STAR to discuss tracking widespread fog with satellite imagery. It's a big deal this time of year, so I know a lot of people want to tune in for that. In the meantime, as has already been mentioned, if you have any questions for our Tower S team, Kashad Bowman, Emily Maddox, we are here to help, whether it's about the Satellite Book Club or the configuration of satellite products. Find us on the Slack channel, contact us via email, whatever works for you. With that, we'll wrap it up for today. Hope everybody's winter's going well. Hope to see you again next week. Thanks again to our presenter, facilitator, and all of you for being with us. Take care.